All right, so if our acceleration is negative 32, then that tells us that our velocity, our velocity should be at any time negative 32t plus some constant. And we know that at t equals 0, that velocity is 40. So that tells us that 40 equals 0 plus our constant. So we have a velocity function of negative 32t plus 40. And then if it takes 4 seconds to hit the ground, did it tell us how tall the building was? That's what we're looking for. Okay. All right. So then we're going to have to look and see what our position equation is. All right. So what's our position equation going to be? It's going to be the integral of this. So what will that be? That would be negative 16t squared plus 40t plus some other constant. I'm just going to make that one d. And we know that, let's see, it takes 4 seconds for it to hit the ground. That means that its position will be 0 after 4 seconds. So 0 equals negative 16 times 4 squared plus 40 times 4 plus that constant. And what does that give you for that constant? 96? Does that sound right? Did I arithmetic right? Or no? Is that an answer choice? That's an answer choice. I probably arithmetic right. Yeah. So d equals 96. So that tells us that your position equation is negative 16t squared plus 40t plus 96. And so the initial position of it would be the position when t is 0. At t equals 0, x equals 96. So 96 feet. Choice B. Everybody good there with that one? Sarah, you good with that one? Yeah. Cool. Other questions from that? 2. Number 2, we got A of t is 20t cubed minus 6t. And it tells us that s of negative 1, that's a position, right? S of negative 1 is a position at negative 1 is 2. And that s of 1 is 4. And we want to find what v of t is. Okay, so first off, to find a basic equation for v of t, we're going to need to do v of t equals, the integral of both sides of this. So our integral will become 5t to the 4th minus 3t squared plus some constant. And we have no way to solve for that constant because we're not given anything about the velocity at any time. So what we then need to do is we need to integrate that to get our position function s of t, which will be t to the 5th minus t to the 3rd plus c times t, right? Because that's just a number, so we'll integrate that. Did I make a mistake with my integration? Oh, I did say, yeah, why did I write t to the 4th? I said t to the 5th. Yeah, no. T to the 5th minus t cubed plus constant times t. And then what do we have to add to that? Since we integrated again, we have to add another constant. We'll call that one d. Yeah. And so now we're given 2 different positions at 2 different times. So we should be able to plug -1 in for t and 2 in for s of t, and then 1 in for t and 4 in for s of t, and have a system of equations with 2 unknowns. So what? What do you mean plus 2 minus 4? I'm not sure what you're saying, but I'm gonna plug in 2 as S of t, and then I'm gonna plug in -1 for t. And that should give me, so this becomes a -1. This becomes minus a -1. So -1 minus a -1 should be 0. So we get 2 equals -c plus d. And then we should do that with S of 1 equals 4. So we should get 4 equals 1 minus 1 plus c plus d. Or that 4 is equal to c plus d. Does that make sense? Yeah. And so then we'll just solve that system of equations. We got 2 different equations with 2 different unknowns. C and D are the unknowns. You can either subtract one from the other or add them together. I'll just, I don't know, let's just add them together, right? 6 equals -c plus c is 0. D plus d is 2d. So d must be 3. And if d is 3, then c must be 1. And I don't know, what did they even ask us? What is v of t? We didn't need to find d, I guess, but that's fine. V of t is 5t to the 4th minus 3t squared plus 1, which is choice B. Does that make sense? Cool. It's a good one. It's fun and exciting.
So how'd you go from the 4 equals c plus d to the 6 equals 2d?
I just added these 2 different equations that I had for c and d together. 2 plus 4 is 6, -c plus c is 0, and d plus d is 2d.
Okay, thank you.
Does that make sense? Yeah. I mean, just, it's just a system of equations. You could also do a substitution. You could solve one of those for c or d and then substitute it into the other one. Whatever you prefer for solving a system of equations.
And so had we only been given 1 point, it wouldn't have been possible to solve this equation or solve this problem?
That is correct. Luckily, they gave you 2. Other questions? And we'll do 7 and 8 after that. All right, so number 10. We got an object moving up and down along the y-axis with the velocity v of t, which is the derivative of its position. Then it is false that. Okay, fine. These are always fun ones. It is false that the integral from a to b of v of t dt. So what does the integral from a to b of v of t dt give us? Like, just what does that tell us? For a particle moving, what does the integral of the velocity do from a to b? I know there's like 5 different answer choices there. We'll deal with them all in a second. But what does this tell us? Yeah, it tells us the, well, not quite the position. It tells us the displacement. So how far it goes from A to B, right? So this is the displacement of the particle from A to B. Right. Which, if we had an initial position at A, we could figure out the position of it. So if we look through here, choice A is S of B minus S of A. Right? Choice A says S of B minus S of A. Well, that's true, right? Because the integral of velocity is position. And if you integrate velocity, you get S of t, and then you evaluate it at the top, and you evaluate it at the bottom, and subtract it, right? So that's good. Part B, the net distance traveled. Okay, that's bad terminology, really, the net distance. But the net distance traveled is the same thing as displacement. So choice B, net distance. That's good. Choice C, total change in position between t equals A and t equals B. That's good. Right, that's the total change in position. Because S of t is the position. So that makes sense, right? It's the change in its position. D, the shift in the object's position. Sounds kind of the same, right? Shift in position, yep. That's true. And so E, which says total distance, that is not the case, right? It is not the total distance traveled. Then, if we want the total distance traveled, what do we have to do with the velocity function? Take the absolute value. Everybody good there? Okay, wonderful. All right, what is it, 7 and 8? 7. All right, number 7, a stone is thrown at a target. Its velocity is 100 minus 20t. And if the stone hits the target in 1 second, we're looking for the distance between the target and the slain. Yeah? Okay, so for this one, we're looking at the change in position, which means we're going to have to integrate a velocity. So if we integrate our velocity, that ought to give us position, which should be 100t minus 10t squared plus some constant. And let's see here. We know that it hits the target in 1 second. Hits the target in 1 second. Let me think about that for a second. Takes 1 second. If you put in 1, it's not going to let us solve for that constant, is it? Oh, no, thanks. That doesn't. Okay, yeah, sorry. At t equals 0, the position is 0. I should be thinking better. Right, at t equals 0, the position is 0. So our constant is 0. So we just end up with the position function 100t minus 10t squared. And so then we'll plug in 1 for our time. 100 minus 10 times 1, which is 90. So it should be 90 feet away. Choice B. Everybody go with that? Yeah. 0 to 1. Yeah. Yeah. Oh, yeah. It's just asked for. Yeah. Yeah. 0 to 1 would work too. Yep. Same thing. Everybody good there? All right. Number 8. What should the initial velocity be if you want a stone to reach a height of 100 when you throw it straight up? Let you reach a height of 100. So you want the time when it stops going up to be 100. We know that the acceleration is negative 32, right? And so then that tells us that our velocity ought to be negative 32t plus some constant. And we're going to have to figure out what that constant is eventually. Yeah, we need the position equation though, which should be what? Negative 16t squared plus that first constant times t plus some other constant. And we want when the position is 100, we need it to stop going up, right? All right, well, let's see how this goes. We need this to be 100. Actually, let's do this again. Our position is 0 when t equals 0. So that'll be 0 plus d, which is going to give us a constant of 0 for d. So then we have the position is negative 16t squared plus t times t. And we have a position of 100. Why is that not working out nicely? Go straight up. Oh. No, that won't do it. Oh, the velocity should be 0 at the time when the height is 100. So we could say that negative 32t plus c is also equal to 0, because we need the velocity to be 0, which would tell us that this constant should be equal to 32t. That'll do it. And that'll give us 100 equals negative 16t squared plus 32t times t, so plus 32t squared. That gives us 100 equals 16t squared. 100 minus 16 ought to be, what is that, 84? Velocity v. All right, so then our time is the square root of 84, at which it's going to stop. And so then we'll go back in here. That's not going to come out right, is it? Oh, I didn't divide by 16, I subtracted. Okay. Yeah, what does that give us then? 10/4. T equals 10/4. T equals 5/2. That's better. Then we'll plug that in. Velocity equals negative 32 times 5/2 plus that constant, which was 32 times t, which was 5/2. Oh, lovely. That came out to be 0, huh? All right. Negative 32. So, right. So we got this 5/2. This 5/2 is correct. We have velocity equals negative 32 t plus that constant that we had. So we need to, which I didn't recognize until I flipped the book and looked at it. That when t equals 0, v is the initial velocity. And so that tells us that the initial velocity is also equal to that constant. And so that constant, which was 32t, ought to be 32 times 5 halves, which ought to be, what is that, 80? Does that sound right? Yeah. 80. I wouldn't expect to see one that's got that many steps on the AP test for sure. Nah, it's kind of a pain. Everybody good with that one? Other questions? $18, sure. All right, 18. We have f of x satisfies the equation that f of x, f prime of x is equal to x, and f of 0 is 1. F of x, f prime of x equals x, and f of 0 equals 1. And we're looking for a function to satisfy that equation, okay? So, two different ways that you could go about this one if you wanted to. Probably I don't know, probably what I would do, honestly, if I was doing this one, is I would just take a look at each of the answer choices. And I would see if, really quickly, if they make sense. So like I would take a look at something like C, where f of x is x, and say f of x, like choice C, I'd say f of x is x, f prime of x is 1. That equals x, so it satisfies the first part. And then I would say f of 0 is 1. Well, f of 0 is not 1. So I'd say it's not C. I'd probably do the same thing with D really quickly to see if that one worked, because that one's really easy to evaluate. F of x is e to the x, and then times f prime, which is also e to the x. That does not equal x, so that one doesn't make any sense. With choice E, you'd have 1/2 x squared plus 1 times 2x as your derivative, and you would see that that is not equal to x either, right? Because it's x plus 2x, which like that's 3x, so it's not that one. So then it's going to be either A or B. Derivative of x squared, or square root of x squared plus 1 is 1 over 2 root x squared plus 1 times the derivative of x squared plus 1, which would be 2x. So that does equal x. And then I'd plug in f of 0 and say f of 0 is 1 and say, looks like it's choice A. And then just to show choice B, it ought to be f of x, and 2 root 1 minus x squared times negative 2x. That one comes out to be negative x, so it wouldn't be that one. That makes sense. Yeah, I think that's the easiest way for that. Other questions? $29? $21. $21. dy dx equals k over x. K is a constant. Y equals 2 when x equals 1. Y equals 4 when x equals e. We want to know x equals 2 when y equals something. All right, so we'll separate the variables on this. So we're just going to have dy. No, you don't even really need to separate them. I guess there's no y, so you don't need to separate anything. You just integrate. This becomes y equals k times the integral of 1 over x, which is natural log absolute value x, plus some constant. And then again, we've got two different constants here. One is k and one is the c. And so you're going to have to set up a system of equations to solve those by plugging in both of these initial conditions that they gave you. So 2 equals k natural log 1 plus c. So that ought to tell you, since the natural log of 1 is 0, that gets rid of the k there, so that tells you that c is 2. So now you've got y equals k natural log absolute value x plus 2. And so then we can use the other one when x is e, y is 4. So 4 equals k times natural log of e, which is 1, plus 2. And so if natural log of e is 1, we would need k to be 2 also. So then we'd have y equals 2 ln absolute value x plus 2. And then when x is 2, what is y? Well, y would be 2 ln 2 plus 2, which is not one of the answer choices they wrote there because they took the 2 that's the coefficient out in front and brought it in as a power inside the logarithm as natural log of 4 plus 2, which is an answer choice. Good? Yeah. All right. Somebody was asking for 17. 17 says the general solution to dy dx equals y. Well, if you integrate dy dx equals y, you get equals y, right? Yeah, just integrate that. You got to turn that into dy over y equals dx. Now, we shouldn't need to do this because we should recognize that this is got a constant of a 1 there, right? This is our separable differential equation that we did, dy dx or dy dt equals ky, dy dx equals k times y. So this should come out to be an exponential, but we can show that that's true by integrating both sides. And then you raise to the power of e. So you end up with y equals e to the x plus some constant. So these are exponential curves. So it looks like that's choice E. You really want to recognize anytime you see this, dy dt equals k, some constant times y, this is exponential growth. This is an exponential equation. Either exponential growth or exponential decay. If you saw something like this, dy dt equals t, what kind of growth would that be? What would you get if you integrated that?
Parabolic?
Yeah, it would just be parabolic, right? The integral of this is y equals t squared plus some constant. That's parabola. Right? If I had dy dt equals t to the second, well, you just integrate, right? And this would be cubic growth, right? When you integrate it. If I just gave you dy dt equals 7, well, when you integrate that, what do you get? You get linear growth, right? So, yeah. Fun and exciting. Everybody good with that one? Cool. Other questions? We got maybe time for one more. And I will have, I'm still going to have review session, at least one review session, maybe two before the AP test. I know we're starting to cut it close, but I'm trying to figure out when my kid has baseball on Saturday. So as soon as I get that figured out, I will be able to tell you when all the sessions will be. But for sure, at least one, maybe two. I might be able to do a second one. So I can go over any other questions you guys might have on any of these during those two. And I recommend, I'm going to tell you this now, I'm also going to put this up in Google Classroom, that you go back to the videos of the review sessions I did for May 4th, whether you were in them or not, and rewatch at least the first two, because those first two, I sort of just covered everything for the entire class and like talked about things that pop up fairly often on the AP test and like some specific problems to do with those. So like those would be really helpful to rewatch. You could also rewatch the third one if you want, but I was just, I think, doing a bunch of random questions that people asked. So rewatch number 1 and 2 from the AD review session before Monday. Those of you taking the 24th test. Yeah. Cool. Anybody have any other questions right now? I just wanted to say that for all the people that are gone today. 23. All right, the slope field at the right. So they give us a bunch of different things here. X plus y. And then when you look at the slope field, I know you guys can't see the slope field, but you should be looking at it in your packet somewhere, number 23. The slope field, you'll note that every single column of numbers for every x value, those slopes don't change. Right, so like if you look over there at, I don't know, it's kind of hard to see what they've got this all marked up on here, but yeah, it looks like it's, you know, maybe over there at around 2, all of the slopes when x is 2 are all 0, right? No matter what y is. And just to the right of that, all the slopes are positive 1. And just to the left of that, all the slopes are negative 1, right? So hopefully you all see that. You all see that? Yeah. So what that tells you is that the only thing that affects this differential equation's the slope of those little pieces is the x values. The y values don't matter. So right, when x is 2, the slope is 0, no matter what y is. So anything that involves a y in it, we can ignore, right? Because the y value has no effect on those slopes. So then we'll look at that. Well, it looks like when x is 2, the slope should be 0. Well, that wouldn't be the first one, but that would work for the next 2. So then you just need to plug something in that's a little bit more than 2 and see that you need to get a positive slope. So if you plug in something a little more than 2, then you get a positive slope from this one, but you get a negative slope from that one. So that one wouldn't make any sense. Does that make sense? Yeah. Cool. All right, that was the bell. So we will, if you guys do have any more of the differential equation questions tomorrow, we can still do a couple of those. We'll also do the further applications of integration and further applications of integration. What? Yeah, it's actually the section before this one. But, well, it don't really matter for you guys because you don't have to book in front of you. But that's it. That will be it. We'll do that tomorrow.